Hey guys, we're back with lesson 2. This lesson is going to be a lot shorter than the last one. So bear with me. We're going to go through it pretty quickly. We're going to click through the slides to see the review activities for today. The student is expected to distinguish between physical and chemical changes in matter. What this means is that we're going over the same type of information that was gone over in the first presentation. Be sure to review the information given in 7.6 Lesson 1 to increase your success in Lesson 2. What that means is, go ahead, make sure that you did Lesson 1 before you view this video Lesson 2. Activity 1. Practice differentiating examples of physical and chemical changes. You will need one piece of paper and something to write with. We're going to be able to differentiate between physical and chemical changes in matter. What I want you guys to be able to do is to be able to justify your answer. So instead of writing it on paper and you would like to send it to me through a Google Doc and I can correct it, I will do that as well. So you'll have 1 through 18. You'll write either P for physical change or C for chemical change for each slide. Once you have committed to your answer, write a brief justification. A justification is a reason for your answer choice, why you chose that answer. We're going to go ahead and begin. If two clear liquids come together and create a new color, is this a chemical change or a physical change? At this time, go ahead and pause this video and then write your answer. Number 2, a pencil breaks in half, a chemical change or physical change? Pause the video, write your answer. Number 3, you have sugar here, and then you add sulfuric acid to the sugar. What comes out of it is gas and bubbles in a new substance. Is this a chemical change or a physical change? Pause the video and answer the question. Right here, you take an egg and you crack it. You put it into a hot frying pan. The clear part of the egg starts to turn white and it cooks. Is this a chemical change or a physical change? Pause the video and write your answer. Right here, the churning of the food in the stomach, where your stomach muscles contract and break up the food. We are not talking about the stomach acid. We are just talking about the stomach breaking up the food. Is this a chemical change or a physical change? Go ahead and write your answer. You take fire and wood and put them together, and then the wood burns and turns into ash. Is this a chemical change or a physical change? Justify your answer. Right here, you've got fruit rotting. It's going from fresh fruit to rotted fruit. Notice the discoloration of the fruit. Think about if you have rotting fruit, what it smells like, what it would taste like. Is this a chemical change or a physical change? Go ahead, pause the video, and justify your answer. Number 8, mixing of food molecules with acids and enzymes in the stomach and intestines of animals. Is this a chemical change or a physical change? The acids and enzymes are being mixed with the food. What happens after this? Justify your answer. Number 9, you take Alka-Seltzer and put it in water. It starts to bubble. What happens here? Is this a chemical change or a physical change? Justify your answer. You take bleach and pour it onto blue jeans. The blue jeans change color. Is this a chemical change or a physical change? Justify your answer. Number 11, the leaves are changing color in the fall. They turn color. What's happening inside of those leaves? Is it a chemical change or a physical change? Pause the video and justify your answer. Number 12, you have ice. You add heat, it turns to water. You add more heat, it turns to water vapor. Is this a chemical change or a physical change? Is it changing state of matter or is it changing its substance? You tell me. Justify your answer. Number 13, bread, meat, some type of, we'll say that's mashed potatoes. I don't know. You take that, you put it through digestion, and out comes glucose, your amino acids, and your fatty acids. Are these the same substances? So, is it a chemical change or a physical change? Justify your answer. You take vinegar and baking soda, put them together, it bubbles up. Is this a chemical change or physical change? Justify your answer. An old subway train is rusting when it's left out in the rain and air. Is this a chemical change or a physical change? Can you get that metal back after it rusts? You tell me. Some of your parents don't like it when you leave your bicycles outside because it will rust. Why is that? Can you get that metal back or do you have to get a new bicycle chain? Justify your answer. You have one substance and another substance. They come together, they react together, and then you get a different substance. Is this a chemical change or a physical change? Justify your answer. I'm chewing my food. I'm breaking my food down. Is this a chemical change or physical change? Justify your answer. After I've chewed my food, my saliva has enzymes in it, and the saliva starts to break down the food. Is this a chemical change or a physical change? You tell me. Justify your answer. Activity 2. Since you're at home doing some snacking, you might find the types of chemical and physical changes during digestion interesting. So make yourself a sandwich or grab a snack and watch this video. This video is 11 minutes long, so if you would like to stay and watch the video on this video, you may do so, or you may go watch it on your own and then fast forward this video.
So, what are you two up to?
Oh, hey, Rosie. Hey, Rosie. We're doing homework.
I see. Is it science homework?
Yeah, I have to tell the difference between a physical and a chemical change. And I have to describe what happens to food during digestion. Can you help us?
I think you two could help each other by working together.
But we're doing completely different assignments. Yeah, what does digestion have to do with physical and chemical changes?
Well, Tanner, let's start with digestion. Do you know what happens during digestion?
Not really. I know. I'll look it up in the big, dusty book of boring science.
If you think that's a good idea.
Here it is on page 1566. Digestion is the process of breaking down food by mechanical and enzymatic action throughout the gastrointestinal system into substances that can be absorbed and assimilated by the organism.
So, you're clear on that now, huh?
Not really.
I'll tell you what. I've got a friend, Natasha, at the Health Museum who can probably help. Why don't you head over there? You can share with us what you learn about digestion when you get back.
Okay. I'll call you when I get there.
Victoria, you can record the changes in digestion that Tanner describes and sort them in physical or chemical changes.
I'm not sure that I can do that.
Sure you can. Let's do a practice run. First, tell me what the difference is between a physical and a chemical change.
Let me see. In a physical change, you have the same stuff, but it might look different. And then in a chemical change, you have something new, right?
Those sound like good definitions to me. And how would you recognize a chemical change? Do you know of any clues that let you know a chemical change has occurred?
Sure. Sometimes there is a color change. What else? Sometimes bubbles were produced. That's how you know a gas was formed. Oh, sometimes a chemical reaction can be exothermic, or endothermic, or
it can make a precipitate.
Whoa there, slow down with all that fancy terminology. What does all of that mean?
Exothermic means that it heats up. Endothermic means it gets cold. And a precipitate is a solid that forms when you mix two liquids. It's a new substance, and it settles to the bottom.
Okay, so here are 8 cards with a change written on each one. Just use your definitions and sort them into physical or chemical changes.
You should pause the video here and try this for yourself. Did you finish sorting your cards? I think I know how to sort them.
Okay, show me what you've got.
This one was easy. When you tear paper, it's still just paper. It's a physical change. Burning paper seems like a chemical change. You definitely make new stuff. You have ashes and smoke. Plus, it's for sure exothermic. I mean, fire's hot, right?
Right you are.
This one was also easy. When ice melts, it looks different, but it's still just water. This is a physical change. In elementary school, we mix vinegar and baking soda, so I know it makes bubbles. The bubbles are a gas forming. That's something new. So this is a chemical change. I wasn't sure about this one. It looks like the sugar disappears when it dissolves in water, but I know it's still there because the water is sweet. I'm going to say that this is a physical change.
That is some clever thinking, Victoria.
So you have some cake mix, and you stir in an egg and some oil and maybe some water. You still have all these things. Mixing cake batter is a physical change. So now you bake the cake. I'm going to call that a chemical change.
So how did you come up with that?
Well, you get something new, right? The cake. Plus, there's a color change. And the cake rises because tiny bubbles are formed. Well, I can't see where it comes from, but rust definitely seems like something new. I mean, it is definitely a different color, so I would put this under a chemical change.
I would say you did a great job. I bet Tanner is about ready to check in. When he describes a change of digestion, why don't you model it here? Then record it so we can sort all of the changes, just like you did with these.
How am I going to model the changes of digestion?
Just use that plate of sandwiches, and we'll improvise the other materials.
Hi, are you Natasha?
Yep. Rosie told me you were coming. Come on in and let's explore digestion. This is where it all starts. Digestion begins here in the mouth. The teeth tear, chop, and grind food, breaking it into smaller pieces.
Got it. Let me check in with my friend.
Hey, Tanner. Are you at the museum?
Uh-huh.
Okay, I'm going to model everything here.
Cool. Okay. Digestion starts in the mouth. The teeth tear and chop and grind the food.
Okay, got it. Tear, 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 chop, 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 grind, grind, grind.
So what else happens in the mouth?
Well, salivary glands produce saliva, which moistens the food.
Saliva makes the food wet.
Got it. Saliva moistens the food.
Saliva also has enzymes, special substances that break starches in food down into simple sugars.
Cool. Enzymes in saliva break down starches, like you find in potatoes, rice, or pasta, into sugars. So what else happens in the mouth?
Well, the tongue pushes the food around and makes it into a small round shape called a bolus, which is easier to swallow.
The tongue shapes the food into something called a bolus, basically a round blob. You got that?
Got it. So the tongue shapes the food into a ball.
Okay, so once you swallow, the food slides down a tube in the throat called the esophagus to the stomach. The stomach is a muscular pouch that can mix and mash the food.
Okay. The stomach is a pouch and muscles squeeze to mix and mash the food.
This will do nicely for a stomach.
The stomach also adds gastric juices, which have other enzymes. These enzymes break down proteins, which you find in meat, cheese, fish, eggs, and beans, into smaller molecules called amino acids.
Uh-huh. You got all that?
Yep, got it. Gastric juices have enzymes that turn proteins into amino acids.
By now, the food is pretty broken down. It's a thin paste, and we call it chyme. The The chyme moves through a narrow tube called the small intestine. Any idea how long the small intestine is?
I don't know. 6 feet long.
More like 20 feet long, and the food gets squeezed along slowly by muscular contractions.
After the stomach, the food moves onto a narrow tube, the small intestine.
More enzymes get added in the small intestines. The small intestines produce their own enzymes, plus bile from the liver is added, as well as enzymes from the pancreas. The enzymes from the small intestines turn carbohydrates, these are the starches we talked about, into simple sugars. Bile has enzymes that break down fats, like you'd find in fried foods, oil, or butter. The enzymes from the pancreas can break down carbohydrates, fats, and also proteins. After the small intestine, we get to the large intestine. The large intestine is a tube about 5 feet long and 2 inches wide. Here, mostly water gets removed and some salt.
Okay. You got that? 5 feet of tubing and water removed.
Got it.
Salt is supposed to be coming out also. Is the water a little salty?
Yeah, it's a little bit salty.
That's about it for digestion. From there on, it's more about elimination.
Hey, thanks, Natasha. I'll see you later. Yeah, I'm on my way. I'll be there soon, and I'll share my notes with you.
So you two have a list of all the changes that happen during digestion. Now you just have to sort them into either physical or chemical change.
Why don't you pause the video, make a T-chart, and sort the list yourself?
Here's how we sorted our list. What do you think? Does your T-chart match ours?
Why don't you pause the video here and talk to a partner about how you sorted your list?
Here's our thinking. You can decide if it makes sense to you. When teeth cut and tear and grind food, it doesn't make something new. It's like tearing paper. Making something wet is a physical change. Same thing with rolling something into a ball. It's just a change of shape. Mixing and mashing something doesn't give you something new. Neither does squeezing something. Removing water is like adding water. Something new is not made. These are all physical changes.
Right. But in all these changes, we got something new. In the mouth, starch is turned into sugars. In the stomach or the small intestines, other enzymes turn proteins into amino acids, or broke down fat into smaller molecules. That's all chemical change.
Are you sure those are chemical changes in the small intestines? Remember your evidence for chemical change. Is any of that evidence present?
Like what?
I don't know, like, for instance, bubbles? Are there any gases produced?
Gases produced during digestion in the small intestine.
Hey, Walter, cut that out. I'm trying to do science here.
I'm so glad you two were able to figure things out.
Yeah, it was easier than we thought.
Walter! I told you to stop with that tuba.
Okay, I hope you guys got all of that. There were some activities going on during the video that you could have paused and done on your own. When it talked about talk with a partner, go ahead and talk with your parents about it. I'm sure that they are very interested in what you're learning and making sure that you're on track, and they might learn something as well. All right, so that's it for our lesson for today. Again, it was a lot shorter than the last one. The video did make it a little bit longer, but you could have watched it on your own and paused it and come back to it. Also, if you guys have any questions or you want to send me a Google Doc of your answers, I can check it and look over it for you and send it back to you. Next week, we are thinking, or the district is thinking about going into Schoology, and we will be doing Ingenuity. Some of you have heard of that before. Some of you guys may know it as E2020. And they will have activities for you to do there. But that's it for this week. I hope you enjoyed yourself. Go ahead and make some chemical and physical changes if you'd like. Send them to me. If you'd like me to post it on the YouTube channel, I can do that as well. Just give me permission. And that looks like it's about that for today. I will see you guys all next time. Bye.